So today we're going to look at the volume of cylinders, spheres, and cones word problems. And before we begin, we need to make sure that we are proficient in calculating the volumes of each of these solid objects, as cylinders, cones, and spheres, using the formulas that we've been working on. The formula in this case here is going to be a sphere. We've got gumballs is what we're dealing with. I've never seen a gumball that's not that's a cone or a cylinder, so it must be a sphere. We're being given a radius of 6 millimeters. So we have our volume here is the volume is 4 over 3 times pi times r cubed. Okay, that's what we have for starters. We can also see that we're going to have to calculate 4 of these. So all 4 gumballs is what we asked. The total volume of all 4 gumballs is that she gets. So we're going to have to multiply this times 4 as well. So let's set up the entire problem. Okay, 6 millimeters is our radius. So we're going to plug that one in first. That's going to be 6 times 6 times 6. There we go to start with. Okay, 6 times 6 times 6 is r cubed. Okay, we can also see that we've got a 4 over 3 that we have to multiply here, so that's 4 times 4, and that's going to be divided by 3. So that's going to be divided by, so times 4 and divided by 3. Okay, and then finally we're going to multiply this times 4 for the 4 gumballs. Okay, so this is what we've got going on right here. Okay, we've got r cubed, 6 times 6 times 6. We've got times 4 divided by 3, and then we're multiplying times 4 as well for our 4 gumballs. Okay, so 6 times 6 times 6, well, we're not going to work that out yet. We're going to get rid of this 3 first of all. Because we see common factors, so we're going to get rid of that 3. And now we have 2 times 6 times 6 times 4 times 4. So let's break this up into separate parts. 6 times 6 is 36 times 2, and 4 times 4 is 16. And don't forget your pi. Okay, 2 times 36 is 72, and 72 times 16 we will do separately. So 72 times 16, 6 times 2 is 12, carry the 1, 6 times 7 is 42, plus 1 is 43, and a 0, we got 72, for both those 1 times 7, 1 times 2, and adding these together gets us 1,152 pi. Okay, so we got 1,152 pi. Do not forget your pi. This is the number of millimeters cubed that we have to deal with right here. Okay, next problem here we have is a cylinder. Again, so let's restate our formula before we begin. The cylinder here, the volume of a cylinder is pi r squared times h. So right here, we've got our pool here. We're being given the radius and the height. But let's read the question to make sure that we've got everything that we need. They've got a backyard kiddie pool with the Ming family with the dimensions shown. This is the pool, the dimensions of the pool. After a lot of splashing one afternoon, the pool is only half full. What is the volume of the water remaining in the pool? So just finding the volume of this cylinder is not enough. We also have to consider that it's only half full. So we're going to have to divide by 2 in our calculation. So let's set it up. Radius here is 4. Height is 2. Let's deal with those separately. Let's plug them in. So we've got 4 squared. 4 times 4 times 4 is 4 squared. And we've got times 2, which is our height. Okay, Don't forget our pi. We're going to plug that in at the end. But we also have an issue here is we're talking about half full right here, so we're going to divide by 2. Okay, so there's our full calculation, full disclosure on all of that, and let's start calculating. 2 cancels out with 2. 4 times 4 is 16, so we have 16 pi. Okay. I do find it quite easier to set up the problem in its entirety first. It does give you all of the information right ahead of time, and you know that there are things you can cancel out to make the problem slightly easier for yourself. Okay, let's take a look at this cake decorator. We've got a cone we're dealing with here. We had a sphere, we had a cylinder, now we have a cone. All right, so a cake decorator rolls a piece of stiff paper to form a cone. She cuts off the tip of the cone and uses it as a funnel to pour decorative sprinkles into small containers. The cone has a radius of 6 centimeters, height of 18 centimeters. What is the volume of the cone before the end is cut off? Remember, when you cut off the end, that will be a different type of problem. Maybe a problem that you might get here is after the end is cut off, and that would be a subtraction problem. But here, you're actually in luck because all you need to do is calculate the radius of the cone. So, what we have here now is a volume of a cone is equal to 1/3 times pi times r squared. We're being told that the cone has a radius of 6 centimeters. So there's our 6 times 6. And a height of 18 centimeters. And again, once again, I keep forgetting the h right here. Don't forget the h for the volume of a volume. And a height of 18 centimeters. Okay. We are going to need to divide that by 3, of course. Okay, and we're not told anything about the measurement of how much was cut off. So we know that, and the question also here is we know that this is not after the end was cut off or anything like that, because we aren't giving any dimensions of that. This is exactly what we're being asked for. So now that we have it all set up like this, right? Our 6 times 6 for the radius, our 18 for the height, and then dividing it by 3 for the 1/3, we have it all set up. So let's calculate it. 3 goes into 18 6 times. All right, and that's giving us a nice easy problem. That's just 6 times 6 times 6, which of course is 36 times 6 pi. And 36 times 6 is, of course, 216. So now we have 216 pi as our measurement. So I hope that's enough for you to go by. Let me know if you have any questions. Any of these, they're going to be reasonably simple questions. It's all just a calculation of a volume of a cone, a cylinder, or a sphere. The only exceptions in those cases are ones where you need to modify it slightly by multiplying times something or dividing by something else, or even possibly addition or subtraction to it. So there's slight modifications, but it's all of the same. It's all of the same work. Good luck.